Bismillahirrahmanirrahim. Assalamu alaikum. I am Arij and my group member is Amna Shahid, and we are here to represent our final year project, which is RTCAS Real-Time Crowd Analytics System. We are working under the supervision of Mr. Mughis Sarwar Awan and industrial supervisors Mr. Mughis Sarwar Awan and Ms. Aisha Ahmed. We are enrolled in Dr. A.Q. Khan Institute of Computer Science and Information Technology, Kahuta, which is affiliated with University of Engineering and Technology, Texas. The outline of our presentation is
Our project is basically doing four main tasks. First of all, it is detecting that how many people are there in the rebel. For this purpose, we are using V2 camera module. After that, counts the heads of the people. This is done by Har, Cascade and head. So many other head counting algorithms are used. And after that, LPC limit is set. If the rebel exceeds the limit, an alarm is generated to the regulatory authority so that they can take requisite steps. And after that, data storage takes place. Motivation. For our project covers a diverse range. Here we are quoting only three of them. Managing a large crowd is a huge and difficult task, and also administration becomes difficult for it, and also it can result in loss of lives. Here I am quoting an example in past that in Hajj pilgrimage, thousands of people lost their lives due to hustle and bustle caused by large crowd. Nowadays, COVID-19 is a prominent issue, and in this situation, maintaining social distancing in a large crowd becomes a difficult task to accomplish. Problem statement. Our mission is to design such a system that can analyze a crowd and keeps a check on it. Solution methodology. We follow four main steps. First of all, live results are obtained by PyCamera. Live results are processed by Python, and in the third step, head counting algorithm is used, and in the end, OpenCV will be used with Python to obtain live results. System design. Raspberry Pi 4B is connected to power bank to supply power to board. C-type port will be used here, and then HDMI cable is used to connect Raspberry Pi to LCD. In LCD, live results are shown.
Now, I will brief you about our project using block diagram. First of all, RPI camera will capture a video on which framing is done. After that, pre-processing techniques which includes shadow detection, thresholding, structuring element, morphological filters, water filling techniques and subtraction is applied on the framed video. Next, contours are drawn on the detected objects, which are further tracked by using centroid detection and counting to get the output frame. Trajectories are drawn on the frame to show a processed video, and the end desired output frame is being obtained. The next is the flowchart, which will brief the algorithm we have applied in this system, which starts with capturing the video and initially removing its background. Shadow subtraction is done. Morphological filters are applied and centroids are initiated and counted on the detected objects. Live count is the count of the person in the current frame. The count increases the described limit the alarm will generate to the dedicated authorities, and if the limit is less than the described limit, then the direction of the object is observed. If the object is moving up in upward direction, the up count will be incremented, and if the object is going in downward direction, the down count will be incremented. Afterwards, the trajectories are drawn on the frame to get the desired results. Now, I will show you the testing and results of our algorithm. It starts with the background detection, in which the frame is turned into the binary frame. The second step, background is subtracted and the shadows are removed by applying the thresholding. Next, morphological operations are performed. Then, opening function is applied, which involves erosion followed by the dilation. The closing function is applied, which involves the dilation followed by the erosion. In the fourth step, water filling technique is applied, in which the distance transformation of a binary image is done. In the fifth step, morphological filtered frame and the water filled frame is subtracted, and in the last step, the result is obtained. The innovation, research and comparison between the existing system and our developed system. The first product is crowd analysis using TinyYOLO by LiuGI. Had good features, but the limitation occurs while using the TinyYOLO V4. Lump sum amount of this product is 96,000 Pakistani rupees. The next is the crowd detection camera to prevent COVID-19 by Ashwani Kumar Senha. But the limitation occurs is that it has many back-end errors. Total amount of this product is 41,000 Pakistani rupees. To overcome with such deficiencies of existing systems, we have developed a system which has the following features. There is no need of a dedicated GPU. It is highly flexible. When the changes are required, it can be changed. It is easy to use. It has user-friendly graphical user interface. It is really easy to implement. It has minimal background errors and can be detected easily and solved easily. No architectural limitations occurs in such an affordable price. Here is the live implementation of our system. We have collected this dataset by our own in our university and live tested on our system. As per the random ID is assigned to the person in the current frame, and the direction along with its ID and time is stored in the databases at the back end.
Conclusion: we are using pre-processing techniques in our project. Basically, we use real-time video recording. Counterbalance is maintained to avoid any unmanageable situation. Limit is set, and if the limit exceeds, alarm is generated to the requisite authority so that they can take steps. In future, more tasks are planned to be achieved. Algorithm is to be enhanced. More accuracy is also to be obtained.
Here are the references we have used for making this system. That's all. Thank you so much.